I'll be talking about question dynamics today. So this is a paper Jakob and I co-authored, and it was published in Scientonomy journal in 2021. So as Paul mentioned in his presentation yesterday, there's been some changes in the ontology of epistemic elements in Scientonomy. So until 2018, there were two elements, theories and methods, that were accepted. This changed after Rowley's suggested modification was accepted and questions were added as a subtype of epistemic element. This changed again in 2019 when methods became accepted as a subtype of normative theory. So right now we have it that there are two fundamental epistemic elements in their ontology, and those are questions and theories. So we currently have an explanation of how theories change, so theory dynamics, how theories are accepted and rejected, and how methods become employed and rejected. What we're missing so far, or before we wrote this, we're missing, is an understanding of question dynamics. So we're trying to answer how questions become accepted and how questions become rejected by epistemic agents. So the plan for today, first we'll talk about question acceptance, and the main problem we'll talk about here is how we can avoid the explosion of presuppositions. Then we'll talk about question rejection, where the main topic is how can a question become incompatible with other epistemic elements. And finally, we'll give a quick example from the history of science. So first off, on question acceptance. So as we talked about yesterday in Paul's presentation and Kai's, there are different relations theories and questions have. So a question can have many possible direct answers, and those are different theories. So for the question, what causes cancer? There may be answers such as poor diet causes cancer, smoking causes cancer, exposure to radiation causes cancer. So all of these theories are answers to these questions. On the other hand, questions also presuppose theories. So the question, what is the distance between the Earth and the sphere of stars, has the presuppositions that the Earth exists, the sphere of stars exists, and there exists a distance between the Earth and the sphere of stars. So we think that it's quite intuitive to say that a question becomes accepted when all of its presuppositions are also accepted. So in order to accept this question, you have to accept these presupposing theories. Sorry, can everyone see my mouse squiggling too? Okay, because I'm going to squiggle it a lot. So to have a better understanding of how questions become accepted, we need to delve deeper into the notion of presupposition. And we drew from the broader literature on the semantics of questions in the broader philosophy of science and logic. And in that literature, a presupposition of a question is usually understood as a claim that is implicitly inherent in and therefore entailed by each and every one of the question's possible direct answers. So a presupposition is a claim that is entailed by all the answers to this question. So any direct answer to this question will imply that the Earth exists, the sphere of stars exists, and so on. So that is the definition of a presupposition. This standard notion is essentially logical because it's just concerning the logical relations between statements. So we advanced a definition of a logical presupposition. So a theory is said to be a logical presupposition of a question if and only if the theory is logically entailed by any direct answer to the question. The issue with this notion of logical presupposition, we think, is that it's explosive because under this definition, any question has infinitely many number of logical presuppositions. So the reason for this is that from a logical standpoint, any theory can have infinitely many logical consequences, if only because in logic, P entails P or Q. So this theory entails, so P entails P or Q, same thing over here, and these also keep going on P or Q, P or Q. And so the issue is that because a theory can have infinitely many logical consequences, a question can have infinitely many logical presuppositions, because all of these and the imaginary ones further on over here, they are also all the question's presuppositions. So to demonstrate this more concretely, this is P, the Earth exists. This also implies the Earth exists or God exists, so P or Q. Similarly, the Earth exists or it is made of cheese. And the same thing for the sphere of stars. So we think that it's intuitive to say that questions are accepted when all of their presuppositions are accepted. But in this understanding, to accept all of these presuppositions, you need to accept an infinite number of them before you accept the questions. You need an infinite number of accepted theories before accepting the question, which we don't think works with finite epistemic agents. And this would lead to an explosion of accepted theories. So because the logical notion of presupposition leads to an explosion, it's not useful for finite epistemic agents. Instead, we propose a notion of presupposition that is epistemic. And we define this in that a theory is said to be an epistemic presupposition of a question for some agent, if and only if the agent accepts that accepting any direct answer to the question will necessitate accepting the theory. So this is strongly agent dependent. The relation of presupposing depends on what the agent thinks. So this will make all the historically inclined among us very happy because it's more friendly to what agents are thinking. And then an implication of this also is that two agents may accept the same questions, but what may be a presupposition for one agent might not be an epistemic presupposition for another agent. So consider an epistemic agent who, when accepting P, nevertheless does not accept P or Q because that would clutter their mosaic and they want to avoid explosion. So for such an agent, which is most agents, not all logical presuppositions of a question would count as epistemic presuppositions. So again, to demonstrate more concretely, the agent would likely accept these presuppositions, but wouldn't accept these ones because they're finite agents and these just clutter their mosaic. So for each agent, the set of epistemic presuppositions is more limited than that of logical presuppositions. So we think that this avoids the horizontal explosion, the P or Q, and exploding that way and that way, but there's still the issue of vertical explosion, because each question can presuppose many theories, as we saw, but each of these theories itself is an answer to a question, which itself presupposes, its own theories, which are answers to their own questions, and then we just keep going on forever. So again, this is a problem because we want finite agents not to have an infinite number of elements. We can demonstrate this visually here. And we think that this can be avoided in practice because we think that there are questions that do not presuppose any theories, and these are definitional questions. So I'll show again. So we have a little ladder of questions and theories. So the question presupposes the idea that the Earth exists, which itself is an answer to the question, does the Earth exist? Which itself presupposes a definition of Earth and existence. And now these definitional theories are an answer to a definitional question, namely, what is Earth? What is existence? And we think that definitional questions are the core of the question theory system, and that this is sort of where the ladder stops. So while descriptive and normative questions, we think, necessarily presuppose at least one theory, definitional questions don't. So in other words, we remember our definition of presupposition as a claim that's inherent in every answer to the direct answer to a question. There are no such presuppositions to definitional questions like what is X? So we escape the vertical explosion this way. And so we escape both explosions and there are no weapons of mass destruction in Scientonomy. So we can now explicate the general mechanism of question acceptance. And so we claim that a question becomes accepted only if all of its epistemic presuppositions are accepted and it is accepted that the question is answerable. So note here, it's not just the acceptance of epistemic presuppositions, which we just went over in detail, that's necessary. We also think it's necessary to accept a second order theory that states the question itself is answerable. So again, we go to our example. This question is accepted by the agent because they accept these epistemic presuppositions and this second order theory that this question is indeed answerable. So that is our idea of question acceptance. Now on to question rejection. So how can a question be incompatible with other elements in a mosaic? So in Scientonomy, the rejection of elements is currently explained by means of a number of theorems deduced from the law of scientific inertia and the compatibility corollary. So for instance, the theory rejection theorem is deduced from the first law for theories, which is that an accepted theory remains accepted unless replaced by other theories, and the compatibility corollary, which is at any moment of time, the elements of the scientific mosaic are compatible with each other. So we want to do, for symmetry's purposes, we want to make a similar sort of theory of question rejection. To do this, we have to ascertain that the notions of compatibility and incompatibility are applicable to questions. So again, there's two main epistemic elements in our ontology. These are theories and questions. So what we're trying to figure out here is can questions be incompatible with theories, and can questions become incompatible with questions? And so we think there's two ways that questions can be incompatible with theories. The first scenario is that questions can be incompatible with theories if there's incompatibility between that theory and the question's epistemic presuppositions. So say you have two agents. Agent A accepts the question, what is the relationship between the four elements? So they also accept the presupposing theory that there are four elements. Agent B, on the other hand, thinks there's only three elements. So you can see that this is only three elements. They say only four elements. So agent B doesn't accept the question, what is the relationship between the four elements? Because they think there are only three elements. The second scenario is when the second order theory stating that the question is answerable or unanswerable come into conflict. So again, agent A accepts question Q. And so they also accept the second order proposition that question Q is answerable. Agent B, however, thinks that question Q is unanswerable, and therefore they reject question Q. So this is the way we think that questions and theories can be incompatible. There's also two conceivable ways that questions can be incompatible with other questions, and we think there's an indirect way and conceivably a direct way. So in the indirect way, the incompatibility between questions is reducible to the incompatibility between their epistemic presuppositions. So again, agent A accepts the question, what is the relationship between the four elements? Agent B accepts the question, what is the relationship between the three elements? So in agent A's mosaic, the presupposing theory is there are four elements, and agent B's that there are three elements. So these two theories are incompatible, and so indirectly, these two questions are also incompatible. This is an indirect question-question incompatibility. We might be tempted to think that there's direct incompatibility between questions, whereas just the questions themselves are directly incompatible. But we think this is quite implausible because questions don't seem to contain propositional content independent of their presuppositions. So it's not clear to us what this would mean, that they would be incompatible except through the nature of their presupposing theories. So we don't think that this sort of direct question-question incompatibility is really there. But the other three scenarios we think do hold, and that this demonstrates the notions of compatibility and incompatibility are applicable to questions. So we can deduce a question rejection theorem from a new formulated first law for questions. So we think that an accepted question remains accepted in the mosaic unless replaced by other elements, namely theories or indirectly other questions. And compared with the compatibility corollary, we get the question rejection theorem, which is a question becomes rejected when other elements that are incompatible with the question become accepted. And we think the scenarios discussed above are indeed covered by this theorem. So we've gone over question acceptance and question rejection, and now to illustrate that this works in practice in the history of science, we're going to do a quick example, and this is from the history of astronomy. So in the late 18th century, William Herschel, that's the father of John Herschel, who's, I guess, a bit more famous. William Herschel was a very well-known astronomer, especially for his work on nebulae, what we might now anachronistically call galaxies. So there was a debate in this period over whether nebulae were composed of star clusters, they were just all stars, or whether they were made of this postulated substance called nebulosity, which is this fluid sort of cloudy substance that some people thought existed. So Herschel did think that nebulosity existed around 1784. And so he posed the question to other astronomers and to himself, which nebulae are composed of nebulosity? And so that question presupposes a theory that nebulosity exists. So this, we can see, follows our idea of question theory relations. However, between 1784 and 1790, Herschel rejected the idea of nebulosity. He thought that nebulosity does not exist anymore. So he also rejected the question, which nebulae are composed of nebulosity? And so we can see here that this question left his mosaic. It was rejected because he rejected the presupposing theory. But that's not the end of the story, because Herschel was quite indecisive. And after 1790, he then thought nebulosity does exist. So he thought that these nebulae couldn't actually all be resolved with sufficiently powerful telescopes into star clusters. They were actually this sort of fluid substantial thing. And so he again accepted the question, which nebulae are composed of nebulosity? So most episodes in the history of science won't show this like quite so clear cut, because I don't think most scientists are as back and forth as Herschel was. But this, I think, illustrates nicely how questions being accepted or rejected in an agent's mosaic really depend on what presuppositions they accept. This is a very short version of this episode, but if you're interested in it more, we do go into more detail in our paper. So some takeaways. To explain the process of question acceptance, we need an epistemic notion of presupposition, because this avoids the explosion that comes with a logical notion of presupposition. We think that the question becomes accepted only if all of its epistemic presuppositions are accepted and agents accept the second order theory that a question is answerable. And finally, we think that the question becomes rejected when other elements, either theories or indirectly other questions that are incompatible with the question themselves, become accepted. So that is all, and thank you very much.
Thank you, Nichole. We are open for questions now. Any question?
So thank you for this very interesting talk. Actually, I was wondering how your model, your dynamical model, could capture the dynamics of how questions change over time. Because, for instance, research questions about the nature of the species were changed drastically between the end of the 18th century and the beginning of the 19th, the mid 19th century. So I was wondering whether this aspect factor in your model.
Thank you very much. That's a great question about questions. That sort of rhetoric kind of plays a lot in this. We have questions about questions. That's really great. So I think that this model can explain it. It does get a bit, not potentially messy, but you can get very fine-grained. So I think when questions change, it may be that the agent then rejects the old question, and that is because their presuppositions change. So I'm trying to think of things from the history of science, but say they learned something slightly different about, some category of species or whatever. I think when that theory changes, then they may reject the old question because they reject the old theory and then accept a new question. Does that make sense? I know it kind of sounds like a really simple answer, but it does get really difficult in the sort of fine-grainedness of it. But does that answer your question? Okay, great. Thank you. Thank you.
Just to address Nicole's question. So when we do those diagrams of questions and the presuppositions, very often it comes down to how specifically you formulate them. If you keep in questions at a very broad level, let's say things like what are the causes of gravity? Let's say early 18th century question that Newtonians ponder about a great deal, both Newtonians and not really Newtonians. So then you see that question perpetuating through time. And then if you formulated sub-questions, which are much more specific formulations, let's say, is the course of gravity a direct intervention of God, or is the course of gravity an indirect intervention of God? So when you get this fine-grained, of course, those questions come and go much, much faster. So the more fine-grained you get, specifically, let's say in the example that Nichole mentioned, you would probably see more volatility in those more fine-grained questions and less volatility at the level of broader questions. Does that make sense?
Question about the relation between question and theory. So the epistemic presupposition that you mentioned, right? So to each epistemic presupposition, you said that there are a theory backing up the question, right? And in an infinite regress, kind of, I think. Or do you think that the regress will stop at some point for some reason?
I think we want to avoid the infinite regress just because most agents, or all agents we deal with, are finite. So we don't want them to have an infinitely large mosaic. So the sort of vertical one, I think, stops when you get to definitional questions. So when you say, like, what is water? What is earth? There is no claim that is a presupposition of that question, because, again, we think that presuppositions are claims that are entailed by all and every possible direct answer to that question. So a definitional questions like, what is Earth? There is no theory that is entailed by every single answer to that question. So that's where we think that the sort of vertical explosion stops. And then the horizontal one, we think it's just if you take a more like a historical agent-dependent view of it, then you can avoid it like that.
Okay, I see. Yeah. So do you think that the epistemic community also plays a role in stopping the chain of
Yeah, so the horizontal one, the notion of epistemic presupposition is introduced in order to stop that sort of horizontal explosion where you have every statement of P implies P or Q, or every statement of P also implies not P, or not P, or not P. So that's again how it sort of goes exploding horizontally. But because all agents you deal with, they're not going to have those ideas in their mosaics. They're not going to think that when you postulate, Earth is this, water is this. They're not going to think water is not this, or water doesn't not exist type thing. So yeah, we think that just taking a more agent relative thing does stop that horizontal explosion.
Yeah, I was just wondering, since when we go all the way up the chain, it's dependent on a definition. Is there ever instances where, depending on, because you start to bring in language as well, and is there ever an instance where one agent has a different understanding of a term, for example, and they're using it different ways? So there's almost an inadvertent schism or a miscommunication just because terms are used differently or loosely or ambiguously once you get to that definitional level.
Yeah, that's a great question. And I think that does definitely happen. Just an example from the history of science in cosmology in the 1950s, for instance, cosmologists would ask, what is the age of the universe? And philosophers would also ask, what is the age of the universe? But they had two completely different definitions for age. For most cosmologists, it was the time since expansion began, so the time elapsed since expansion started. And for philosophers and theologians who were kind of more intense, they were saying, oh no, like it's actually the age as we would think of a person's age. So there's definitely yeah, as Cameron says too, sometimes it's incommensurable and you can really get schisms for that. So I think that's exactly what happens sometimes. Yeah. Does that answer your question?
Yes, perfect. Thank you.
Can I jump in for a second just to clarify that as well? So with situations like that, it's very important to look beyond just a linguistic formulation. So just like with propositions, we separate the semantic content of a proposition from the sentence that expresses it, right? Similarly with questions, it's always very important to separate the semantic content of the question, what exactly it's asking, and not look just at how it's formulated, because for once you can formulate it in 10,000 different languages, and that's not the question itself, although you don't have any other choice, but when you put it on a diagram or write it down, it is written in some language. Of course, that's understood. So bottom line is that two agents not sharing the same definitions, but asking verbally the same question would literally ask different questions. So that's being commensurable, right? So, and in our diagrams, we would have to try and catch that and capture it.
Okay, you want to go ahead?
Yeah, I was wondering if you guys ever tried kind of defining like a minimal set of presuppositions, like of the logical kind. For instance, when we're talking about explosion, it seems that all of these are entailed, like for this, let's say the sphere of stars question. You have those three statements that are kind of evidently the presuppositions. The sphere of stars exists, Earth exists, there's a distance between them. And in a way, they kind of seem minimalish, but the rest of them are kind of implied by those three. But did you try defining a minimal set, or did you find it was like impossible for some reason?
I'm not sure we tried doing that, just because when it comes to logic, I just don't try too much because it all seems a bit silly. So this problem actually we first saw in Rescher's account of questions and theories, and I don't remember if he also tried to define a minimal set, but he didn't. So you would know much better than me if that is possible, and that might be a desirable thing. But I think another reason the epistemic presupposition, like the epistemic notion, is helpful is just because when you are being a historian, you are looking, they still might not follow this minimal requirement for a logical presupposition. They may see something more or something less. So I think the epistemic one just really does capture that agent relativity, which is really important. But I'll let my co-author answer the question about the minimal thing, because again, logic is silly.
Yeah, so I'm having a hard time imagining how we can do that purely logically. That would be lovely if we could, of course. But the one trouble with the idea of minimally logically necessary presuppositions is probably going to depend what two things you accept as axioms and what, you know how it works in logic. You can accept A and B as axioms and deduce C. You can accept sometimes C and B and deduce A. So there's many different ways of doing that. So if we are trying to do it purely logically without any additional epistemic additions, some kind of additional filtration mechanism imposed by the agent, that might be a problem, I think. So I suspect in practice, most epistemic agents are involving some kind of a filtration mechanism that has to do with some economy. You don't want to clutter things, right? It would be great if it was just logic, but I'm not sure it is.
I see. Yeah, I definitely agree on that point. But it would be interesting to try to see if there's even like a potential like common epistemic filtration mechanism or something like that. Because of course you could have the, as you mentioned, the equivalent like axioms that would be accepted from what you entail, but maybe there's ones that are like more evident, like just something exists or something like that. It'd be interesting to explore, but maybe a bit difficult.
I agree. That would be really interesting to explore. It would tell us about, yeah, what their filtration system is. We have to now introduce filtration systems to our ontology. Andrew?
On the idea of like having a minimum tree, I imagine that we'd want to, because you have some questions, like complex questions would have very more complex trees. Are we thinking of ways of like condensing or minimizing a tree such that like we're only looking at certain nodes that, like, for example, bring the most information? Like the idea of like, like if you have like a tree and like a decision tree, like in computer science, it's like the information gain of different nodes or different like theories or questions might be more so than some other ones. And I was just wondering if you were to condense a tree, or if are we thinking about condensing a tree at all, or to just to represent it more like easily, I guess.
Yeah, that's a great question. I think that, yeah, I mean, when you diagram, you can kind of choose yourself what elements to include and not. Like, so if you noticed in the first time I portrayed that question, what is the distance between the Earth and the sphere of stars, there were 3 presuppositions, because it's not just the Earth exists and the sphere of stars exists. You also have to presuppose that there's a distance between them in order to ask about the distance, right? But then that presupposition mysteriously disappeared because I didn't have space on the slides for it. So, and also because it wasn't as important as the other 2 things. So I think you definitely can, and I think diagrams are a really great way of doing that, because you really can highlight visually what's important and not. I'm not sure about the computer science aspect of that, so I'll...
There's always a trade-off when you're diagramming. On the one hand, you're trying to focus on what's important to highlight a certain epistemic aspect of the process, but that always comes at a price in most practical situations, because you cannot do one-to-one reconstruction of the agent's belief system, right? If it's a one-to-one, as Herschel says, if you're doing Aristotle one-to-one, then you just get in Aristotle. It's not possible, so you have to be selective. And when you're being selective, of course, you're trying to capture minimally necessary for providing a certain explanation. But that always comes at a price. In some other context, that particular diagram that works well in one context, in another context, it might be that you're missing some important sub-question there or more specific formulation of those questions. So I don't think there is one universally right way of diagramming. It always depends on the particular task at hand. So you're always trying to highlight, oh, here's the transition I'm trying to highlight, or here's the aspect of the connection between theories and the questions and the presuppositions I'm trying to highlight. So it's always dependent on a task at hand. But if we were to, let's say, put ourselves in a, let's say we have a task that we want to diagram in as much detail as possible, then of course it goes against what you're suggesting.
Okay, so just to make sure, there is like each type of tree like supposes some level of simplification such that there might be some aspects. We're not because I thought that the definition of tree in this context was like, oh, we're trying to capture like almost like if not every possible like I guess like lower level / higher level question / theory. But okay, yeah, no, that's good. Thank you.
Yeah, it's always going to be relevant to like what the diagrammer is wanting to do. Because I think pretending it's exhaustive also is just setting yourself up for failure, because I'm not sure you can make an exhaustive one. But thank you.
Okay, great. Thank you so much, Nick, for your talk.